Coming up in this episode, I will be replacing a Tempress II shower valve. I will be repairing and soldering copper shower supply lines. I will be removing Pex Fittings, and I'll show you how much you can save by doing this yourself. All on this episode of DIY Well. Hi, thanks for tuning in to the first episode of DIY Well. In this first episode, I'll take you midway through a repair of a leaky shower valve that's caused damage to sheetrock down below. Because this valve is so old, it has no shutoff screws, and I'm forced to cut out the sheetrock behind the shower to cut and cap the supplies to the valve. I had to wait for parts to arrive because this valve cannot be bought off a standard big box store shelf. So one of the things I want you to know is that I am not a trade professional. I'm just a DIYer. I do my best to follow good process and procedures for all the repairs that I do. However, I make mistakes. And via the virtue of recording this on the web for everyone to see, everyone will have an opinion and comment on the things that I've done wrong. That's fine. That's part of the learning process. With that said, if you're going to undertake work in your home, please make sure that you pull proper permits and get the inspections done, and always wear the proper safety equipment. So with all that aside, let's go to the repair in progress. This is a view of the Danfoss Tempress shower valve. As you can see, this valve is severely corroded and has caused a leak that has required me to shut the water off to the house and seal the hot and cold water supplies to the shower. The Danfoss valve has no service screws. Water must be turned off to the house before you can remove the cartridge. After shutting off the water and water heater, drain water to the house to reduce the drainage. Remove the 4 screws on each corner and pull. With the valve cover removed, I inspected the valve. The water inlets have raised cast impressions that seat the inlets of the cartridge. On newer models of the valve body, these parts appear to be serviceable. If you have these serviceable parts, this would be a good time to replace them. This is a quick view of the valve exposed from behind. What you're looking at here is the cutout from behind the shower wall, in which I was forced to stop off the supplies, which run from the attic down to the shower so that the valve would stop leaking. This is a Sharkbite push-to-connect 1/2 inch cap. After the water was shut off to the house, along with the water heater, I cut the supplies of the shower and then utilized this temporary fitting to seal the water off to the hot and cold supply of the valve. Because the shower valve is over 20 years old, parts are not easily available, and I had to wait for parts to arrive in the mail. Unfortunately, when you open walls, you will find problems. This was the solder work done when the house was built in 1998. This work is so poor that I opted to cut it out and replace with better work. This will be my first solder job ever. Now I'm going to tell you the process I used to repair the copper lines. My initial work will be in real time, and once you've seen the process once, I'll fast forward through the rest. What you're seeing here is me reaming the pipe. When you cut pipe, it can cause deformities and stray metal that can impact the final result. Because I used a circular cutter that you will see soon, it can actually cause the inner diameter of the pipe to slightly curve in. This reamer uses a blade to scrape away the interior of the pipe to allow for a smooth transition. I continue to do this until I'm happy with the result. Now I'm preparing several segments of the pipe with fiber mesh tape made for preparing copper. I will prepare all pipe ends in this manner. I tend to go overboard with my prep work as I want a successful outcome. I polish all the areas that will come in contact with the fittings and over polish the end a little bit. This is a critical step. In this segment, I removed the shoddy previous work done by what must have been a poorly supervised plumbing apprentice. I use a hacksaw blade to remove the segment, as the traditional pipe cutter does not have the necessary clearance. And again, every segment must be prepped in the same manner. Here I use a round file to lightly abrase the inner diameter of the pipe because my deburring tool does not have the necessary clearance to do its job. I have installed an electric shutoff valve in my house called the Streamlabs Control. This makes it very easy to turn the water off as shown here via my iPhone. I also have my hot water heater on a smart plug and turn it off as well. After these are shut off, I open up the tub water to remove residual water and pressure from the line. As previously noted, I installed Sharkbite caps to cut water supply to the valve. You can either cut these expensive fittings out or, as I prefer, use a removal tool so you can use them again. Each removal tool is unique for each diameter of pipe you're using. These take practice. What I find works best is to place the tool just above the fitting, push up on the fitting, and then apply pressure on the tool from above. You are essentially squeezing the fitting. Once squeezed, you can pull down to remove the fitting. This takes practice and is not easy. Here I'm measuring the pipe to connect the previously capped segment of pipe back to the valve supply that I will be putting in service. I measure and cut fairly exactly as I want the pipe to be fully engaged with the fittings. This is an extremely good circular copper pipe cutter tool that I found to be one of the easiest and most reliable tools I've ever used for cutting pipe. You create your mark, center the tool over the mark, the cutting blade is in the middle, close the ring with a little force to snap it in place, and turn in the direction shown by the arrow. It only takes a few turns. When you are repairing a piece of pipe in the middle, especially for rigid pipe like copper, you will likely need to use a slip coupler, also sometimes referred to as a repair coupler, to ease the repair. A standard coupler has a ridge in the middle. It allows the pipe to only go halfway down before it stops. If you imagine having a coupler like this on both ends, it would make it impossible to use two standard couplers because you wouldn't have room to seat the pipe. If you don't understand this, you will understand it when you try and do it. In this instance, I use a standard coupler on the bottom and slip coupler on the top. At this point, I'm repairing the 6-inch pipe segment for installation. You need to prepare each fitting by using a metal brush and scoring the inside of both ends of the fitting. And now it's time to add flux. There are many videos on YouTube on this, but flux is what causes the solder that you will apply with heat to get sucked up into the joint like magic. There are several types of flux, but I am using a tinning flux. A tinning flux contains some solder in the material to help create a good seal, but this is not sufficient for a seal by itself. I want to have a nice even coat of solder around the pipe, not too heavy and not too light. I struggle a little bit with this because the brushes I have are poor quality and keep shedding on the pipe, and I have to keep reapplying. Make sure your flux is free from contaminants. I'm going to use a slip coupler for the upper segment, but as the slip coupler and standard coupler are the same dimensions, they should be in the same position once fully seated so that the pipe above and below are even inside of the fitting. I use the regular coupler just to add a mark to the upper pipe for guidance. This will be more clear in a minute. All pipe and pipe fittings must have flux applied. I'm going to be adding flux to both pipe segments and couplers. I have opted to place the slip coupler on the pipe segment to be installed and slide the coupler up to the mark. This is not always easy. It took me 3 attempts, 2 starting from above and going down. I first pushed the pipe into the lower segment with the standard coupler, then I aligned the top segment to the upper supply and pushed the coupler up to the mark. Once this is done, thoroughly clean off all excess flux on the pipe surface with a clean cloth. So torches reach extremely high temperatures. So I recommend putting in a heat shield. They're very cheap insurance. You also need to be extremely aware of the dangers of the torch, not just when it's on, but when it's off. During this process, I accidentally brazed the torch after I set it aside and had a nasty burn. So you have to be aware of it. Something else I should mention before I start soldering, you can't solder with water in the lines. So make sure that you've cleared out all water in the proximity of the area you're going to be doing the work, or the solder will fail. Also, get the right solder. Don't use lead for your potable water system. This counts as potable water, so lead free. And in this instance, I'm also using a MAP gas because that allows the melt a little easier. So these are my first solders ever. They are not perfect. It's really hard to do this for the first time while reaching over and around a camera. I should have aimed the flame a little bit lower on the top joint and pushed a little bit more solder, but I was able to see solder when examining the joint after it cooled. Watch some other pro videos before attempting this. And here I'm just preparing to do the other supply. It's pretty much the same thing, and I omit most of the measuring. This is going to require 2 elbows in order to bend around the shower supply. So I'm moving my heat shield again to finish the soldering work for the last segment. I will continue to show this in real time. I think I do a better job of aiming the flame on this particular fitting, keeping mainly on the fitting and very little pipe. So note that I touch the top of this connection with the solder and it doesn't take. So I back away, wait a second, and then re-engage. I believe this is my best attempt. You can see that when I apply the solder, it can visibly see it around the entire tool. So this is the last of my soldering work. So we'll find out in a few moments, once I put the valve back in, if this has been a successful job. So here I have my new valve cover and new cartridge assembly. They came together as one unit. This gets inserted, and then I put in the 4 screws on each corner of the valve after making sure it's fully seated. So before I turn the water back on, I want to temporarily install the shower control valve so that I can make sure the valve is totally off, then turn the water on and make sure I have no leaks. I do want to point out to make sure your copper work and your soldering work has cooled before turning water back on. So the water's turned on. I've seen no evidence of leaks, and I am testing the valve. The valve operates well. One thing that I omitted here that I should have done is taken off the shower head and then flush clean water. Occasionally you can get debris in the line, and it's better not to put that into your shower head. So this is where I ran into a little bit of a problem. I didn't notice, but the valve cover that I got has a slightly different standoff than the new valve cover, requiring me to purchase longer screws and to apply a backing nut to provide some pressure and stability, which I'm doing here. But an easy fix. Nearing completion, and now it's time to put the valve fascia back on and put on the stem cover and put on the control arm and tighten the control arm down with the 2 Allen screws on the top. And I'm finishing it off with a caulk bead around the top. I'm careful to leave some air at the bottom just in case any water gets in behind the fitting. I wanted to be able to escape the fitting and not go behind the wall. And this brings us to why do this yourself? So let's look at the cost breakdown. Our supplies were $169. This includes the $100 replacement valve from eBay. If you don't have the tools, you're going to have to make a one-time investment. That's $131. And that brings us to a grand total of $300 all in for parts and supplies to do this repair. And now that brings us to what a plumber would cost. The supplies are going to remain the same. When I calculate the labor charge, that's a little bit iffy. We're talking about at least one service fee of $125. This will likely be 2 trips, one to diagnose, the second to repair when parts arrive. I've calculated this at 5 hours of labor at $100 an hour. That brings us to $794. More than likely, it's going to be more because plumbers are not going to go search for a valve for a 20-year-old valve. Or a cartridge for a 20-year-old valve. They're simply going to want to replace the valve altogether. That is going to run your cost up. This also does not include the cost of sheetrock repair, which you will have to make at the end. So, what does your savings end up being? Drum roll, please. $633 at least for this repair. So, don't be afraid to tackle your own plumbing repair in your house. It can save you big.